Hey guys, very good morning, and hope this is the first actual maintainer track session after the keynote, and I hope I can give you an overview of chaos engineering, the product LitmusChaos, open source chaos engineering. So today's topic is going to be how we can destroy our production systems to test resilience in a safe way using one of the open source chaos engineering tooling. My name is Sayan. I'm a senior software engineer at Harness, and I am also a maintainer and community manager of a product called LitmusChaos, which is the CNCF Incubating open source project. I also actively participate in LFX mentorship for this product, and we also will be doing the term 3 as well. And lastly, I've been practicing chaos engineering for the last 3.5, 4 years. And these are some of my social handles. So before we jump into chaos engineering, I would want to quickly talk about resilience, why it's required. So there's cloud-native systems everywhere these days with distributed systems, and there's a lot of interdependent failures that occur because everything is connected. So 80% of the cloud-native infrastructure is connected, and if one fails, the other fails because of the cascading downtimes. Also, we have a lot of complex architectures these days. Usually, before we used to ship just one thing, we had less release cycles. Now we have a lot more. So everything is dependent on a lot more things these days with the complicated architectures. So reliability is really crucial. And a lot of the times, we oftentimes test the top of the layer, which is the application layer itself. We never trickle down to the bottom. Rarely do we ever test the infrastructure or the underlying platform services or the cloud-native services. We generally test our application, and sometimes we also test the application dependencies, but rarely do we even touch the infrastructure layer. So this is the application pyramid, the infrastructure pyramid, as we call it. And chaos engineering specifically focuses on touching the bottom 3 layers. You can also do the top 2, but it's like a granular solution where you can test individual layers and also club them together into what we call the reliability proliferation challenge. Now, outages are expensive, and chaos engineering is one of such practices that help prevent them. Now, they do lead to a lot of financial losses and reputational damage, as we know. And they are mainly caused by 3 things from what we know. One is the application failures. Now, sometimes the problem is with the application itself, because a lot of the time there might be bad code, unhandled edge cases, and a lot of the time it's just unexpected system load that might happen due to some traffic injection. Now, like an example of this would be a Slack outage, for example, where there's a lot of logging that the Slack server was doing, and that took down Slack, impacting thousands of businesses that were using it. So this could be one of the application failure examples. And the result would be users lose access to the service that leads to loss of productivity, frustration, and so on. Second is the infrastructure failure. Now, oftentimes, cloud providers and Kubernetes is not really 100% reliable because you could receive device failures like hard drives crashing or power supplies failing or memory leak buildup and so on. Recently, there was another outage where a financial company lost over 55 million with this because they had one of their infrastructure prevented the transactions from being processed. So that took a huge scale of impact, and a single infrastructure issue led to almost millions of dollars of impact per hour. Lastly, it could be operational failures, which are not really dependent on the application. It sort of depends on you as developers, as ops people. Because a lot of the time, it's like things happen, but we are really late at noticing them or sort of identifying and pinning it down to the exact team, and just we don't even know that something is wrong, and until we report it, it's already too late. So it's a lot of the time just the ops team that needs more awareness via alerting, more observability and monitoring. So how can we mitigate this? We can do this by a practice called chaos engineering. And what it does is it's a simple process of testing your system in a reliable way. It's a simulation that you can do in order to be ready for the time when the actual outage happens. It's sort of like a fire drill that you do in the beginning of the application delivery cycle, so that when the actual event happens, you are much more prepared. Now, there are 3 ways you can do it. One is you have to be proactive. Like I mentioned, it's predictive analysis and being proactive. So you are planning things out, simulating them so that you're ready. Second is you analyze the system via different methods, different faults, different vulnerabilities. So these practices help you identify the vulnerabilities at a much earlier stage rather than later. And thirdly, the benefit is that you are reducing the downtime. So a lot of the time people have this question that where do we start this, because it's a disruptive process. Maybe production is not the ideal place for this, which is true. Does not really have to be in production because it's where your application ultimately lies. So we have 3 chunks. One is the local environment where you can get started with K3s, Kind, Minikube, and so on, which is completely you can destroy and just do any experimentation with it. Secondly, once you are happy with it, you can shift it over to your development environments, your UATs, your staging. Finally, when you're comfortable, you can move to QA, your pre-prod, and then finally you can shift it over to prod. Now, let's talk about LitmusChaos, which is the project that we wanted to discuss in the beginning. So Litmus is an open source cross-cloud chaos engineering framework which just gives you the bare bone by itself, and then you can plug and play different monitoring tools, you can induce multi-tenancy in it via multiple agents. You can deploy different APM tools in it. So it's like the bare bone minimum open source chaos tooling, which you can pair with multiple other plugins, sort of. So with Litmus, you do get to inject chaos in multiple other Kubernetes services because it is by the community for the community, and it has support for multiple cloud as well. So once you deploy it in Kubernetes host, you can also target multiple vendors, AWS, Azure, and so on. This is a small timeline view of what we have been doing for the past 4 or 5 years. I'll just talk about the recent half of it so you get an overview of where we are at, what we have been doing. Now, if we talk about the KubeCon North America 2020, this is where we first announced the probes, Litmus probes, which were the resilience probes that we introduced as part of your regular chaos checks. And then we'll shift over to KubeCon 2022, where we added runtime support. We added support for application chaos, which was Spring Boot. We also did the richer CRD schema for faults and validation so that people have a more granular hold on their chaos experimentations. Then in KubeCon EU 2023 in Paris, we sort of announced resilience code-driven UI UX, where basically whenever you do chaos, you get like a reporting enabled, which gives you an overview of what was the score of your application reliability, what needs improvement, what might cause an outage in the future, and so on. So we revamped the UX completely in 2023. In 2024, last year, KubeCon NA, we added a couple of enhanced security features, and recently on 1st of April in KubeCon EU, we announced distributed tracing with OpenTelemetry, and we introduced a couple of more faults. So some stats on Litmus. We are 2 million plus Litmus installation at the moment. We have 68 million Docker pulls, a lot of usage increased in a couple of years, and 21 active maintainers maintaining a lot of things going on, which is a bit hectic, and we have 100 plus releases so far. The recent will be 3.20, and we have a 25,000 plus 2,500 plus active Slack community members. So what does Litmus really do? What are the feature sets? So in its crux, the core feature that Litmus helps you with is fault injection, their experimentation management, and observability. Now with this, you can of course expand it to more advanced use cases like GitOps, where you might want to use Git as your single source of truth. You can also do game days, where you sort of sit down with the team and let them carry out chaos faults for you. You can also do multi-tenancy and CI/CD integrations with it. A couple more integration capabilities would be you can integrate it with Prometheus, Grafana. It also supports air-gapped systems. You can also target bare metals and so on. By default, Prometheus and Grafana aren't installed with Litmus, but if you want to inject, if you want to have observability set up with Litmus, you can of course just do a simple kubectl apply, and it's part of the repository. But if you want to induce or keep your own solutions like Datadog and so on, you can also inject those. We right now support, this is not an exhaustive list by the way, but we right now support a lot of variety of experiments. The range of experiments is more, so that you can do more with less faults, if that makes sense. So the idea behind scheduling a chaos experiment is you club together multiple faults that create a single scenario. So we have pod level chaos, we have node level chaos, network chaos, we also have stress chaos. We introduced a new K6 load gen, which is not there in the slide, and we also do cloud service chaos and application specific chaos, which would be Kafka, Cassandra, OpenEBS, and so on. So this is an overall architectural view of Litmus. I'll just give you a quick rundown of what it means, and we have 2 more slides just for this. So we start off with your persona, which is an SRE, a developer, and so on. And then we have 2 planes, the control plane and the execution plane. So control plane is where most of the application layer lies, which is your GraphQL server, your authentication, your DB, and your chaos center, which is the UI, the front end. And execution plane is where the CRDs lie, which is the chaos experiment CR, the engine CR, and the chaos result CR. So in the execution plane, once the request that you want to inject a chaos is received, the chaos experiment sort of is like a blueprint of the chaos injection you want to do. Chaos engine sort of helps you tune them better. And there's a chaos agent, which is subscriber. There's an Argo workflow controller that helps inject the chaos. And then the chaos operator sort of is doing all sort of validations, policy checks, if you are even allowed to run chaos or not, if you have the required permissions or not. So it's the heart of the entire chaos injection, which is at the bottom, chaos operator. And once it's ready, it sort of starts injecting chaos via multiple chaos jobs. So these are the 3 CRDs once more. We have chaos experiment, chaos engine, and chaos result. Chaos experiment is the pre-build, which is the what you are injecting, and that is the sort of the images, libraries, permissions, low-level parameters, or the blueprint basically. Chaos engine is the user-defined, or the how you are doing it. So what is the interval, what values you're overriding, what is the hypothesis, what are the abort conditions, and so on. And lastly is the chaos result, which is the info, or what exactly happened, what do I learn from it. So you will see the experiment state, the verdict, the attributes, and so on. Here's one more slide on the architecture so that you get things better. But this is the flow of how things work once more. So you have the chaos hub, which is the central repository of all the faults that are available. This is also available in the portal. When I do the demo, you'll be seeing it once more. But it pulls all the references from the chaos hub, which is chaos experiment CRD. Chaos engine CRD is also there, which is tuning it. And the chaos operator is again at the bottom, at the center. And it does chaos via multiple chaos runner pods. So each chaos runner is responsible for injecting specific chaos jobs. So maybe let's say you have given 60 seconds interval. So after every 30 seconds, it will spin up one chaos job, it will delete, and then one chaos job, and it will delete, and so on. So let's get some demo. All right, so this is what I have. This is the deployed LitmusChaos version. But before I even jump into this, I want to show you the terminal quickly. And this is all the pods, all the services, all the pods that I have at the moment. It's deployed in a namespace called Litmus, which is, you can change it, of course. And I just wanted to show you the services really quickly. So we have the auth server, the front end, the GraphQL, and the Mongo, which is the control plane. And you will see there's a couple of other things like the workflow controller, the exporter, which are part of the execution plane. Now at the top, you would also see this, the subscriber, the event tracker, the operator, and the exporter. So these are essentially part of the execution plane. These are not present by default. So when you install Litmus, you'll only see the authentication front end and the database. That's all. So these are two components ideally working hand in hand. the beauty about this thing is you can shift the execution plane to multiple other clusters. So let's say you want to deploy your chaos infrastructure somewhere else in, let's say, AWS. You can do it. You can have Litmus control plane installed in, let's say, Azure. And you can have the execution plane installed in ABCY vendor. So you can target all those vendors via one single point of failure. So I have just taken this external IP, which is my Litmus frontend. And this is how it looks like. I have also taken one demo application, which is online boutique app. And this is the microservice demo application. And you can see there's a front-end external that is having an external IP. What we will do in this demo is we will try to break one specific microservice, which is, let's say, the product service, which is listing all the products in that boutique store. And we'll see how that works, because we are sort of injecting chaos by deleting one microservice. We want to see how it responds and how resilient our service is. So this is the online boutique app, which was deployed. And this is the external endpoint. And this product listing is done via the product catalog service. And this is our Litmus control plane. So we'll go to chaos experiment. We will run a new experiment. You can give it a name. Let's give it a simple one. We'll choose the infrastructure. And in this case, I have already deployed one in a single namespace. That's why you saw both the control plane and the execution plane together. I'll just apply so that it selects. Go on next. So we have 3 different modes of choosing how to inject chaos. It starts with a blank canvas, which is the bare minimum customized option. You can go to templates, which are predefined templates that are available. And then if you're an advanced user, you can also upload the entire YAML. Just do blank canvas. This is how it looks like. We'll click on add. And these are all the lists of predefined faults available. These are also available in Chaos Hub, which is hub.litmuschaos.io. The same thing is available here as well. We'll go to Kubernetes. We'll select pod delete, let's say for now, but you have the option of doing a lot of things. Kubelet, service kill, memory hog, node memory hog, CPU stress, DNS chaos, and so on. We'll just do pod delete to keep things simple. And this will be, of course, resilient because Kubernetes has a deployment and we'll try to bring it up anyways. But just for the sake of the demo, we'll do the target application. We'll select it as a deployment. The namespace is demo. And the app label is the product service, the product catalog service. In the tune fault section, this is the chaos engine CRD. This is where we are modifying the tunables. We can keep the chaos duration as 30 so that it goes for 30 seconds. The rest is predefined. We don't really need to tamper anything. And for the probes, I have already created one, which is a simple health check probe. I don't think you can see it, but what it's doing is at the bottom, it's just checking if the URL is healthy or not. It's a very basic probe. It's just checking if that external IP is reachable or not. So when I select the probe, it gives me an option to choose the mode. We have a couple of modes, which is when do you want the probe to run? If it's start of the test, end of the test, edge is basically before and after, continuous is throughout, and on chaos is when the chaos is specifically happening. So we can just do edge to see if the application is healthy before the test and also after the test is finished, so that it makes more sense. We'll apply the change, we'll save it, and we will run. So what essentially is happening in the background is, if I expand this, let me just, you'll see it's creating a runner pod. It will, not yet. It will do it soon. So what it does is it installs the pod delete or whichever fault you just configured in the system in the background. It'll inject the runner pod. The runner pod is the sort of the helper that spins up multiple chaos jobs, as we saw in the architecture diagram before. When the jobs are spawned, that is when the chaos injection is actually happening. And we will be able to see the specific product catalog service go down because the microservice is going down. And you can see it is the main pod delete experiment that is being in an init state. You can see the runner right now. The runner is sort of trying to inject. You can see one of the chaos jobs. Let me quickly go and refresh this website. And we should be seeing chaos ideally. gave it some time. I think the internet. Yeah. So because it deleted that specific microservice, this is default Kubernetes behavior that it'll bring things back up to healthy. It's not healthy at the moment, that's why you're seeing it. And the way this microservice demo application has sort of done its error recovery or handled the error is via a specific error boundary. But this could be ideally, this could be your transactional database handling microservice, or it could be one of those services where, let's say you have a message queue or anything that breaks and it causes an actual outage in the future. So this is a way for you to verify that something is wrong, and if this specific service is wrong, how can I read out or do things better so that I can help modify that application better. So let me go back. It's still running because it was 30 seconds. Let me refresh. And by this time, Kubernetes has already brought it back because it's not an intra-chaos, so you see the old state again. But now if I go back to the demo application, just for the sake of it, one sec. You'll see the age of this service. One second. Yeah, you can see the age of this service is just 57 seconds, whereas the others are running for a day old. So it just restarted, but Kubernetes brought it back up. So that's ideally how you would be managing and doing chaos in a normal situation. You can, of course, plug these things together and chain them together into multiple different scenarios, create different hypotheses, and this is essentially the crux of how you do chaos. Cool. We'll see a couple of new enhancements and features. So basically, these couple of months, we have been trying to do adding LitmusChao and Go SDK. We, of course, are doing the distributed tracing and document DB support that we can enhance and replace certain MongoDB operations for Litmus that are running on AWS Document DB. We, of course, have another proposal of adding chaos fault for AWS, which is AWS RDS, sort of creating like a blueprint so people can expand it further into something else, something of their own choice via the chaos charts. And we are also adding support for delete abort when experiment is stuck in the queued state. Now we also have the roadmap available on the repo. Some of the pressing items in the roadmap are AI integration, of course, with toolings like KHGPT and so on. We want to implement Kubernetes connectors to also enable streamlined integration with the Kubernetes controller. We want to integrate Terraform support for infrastructure as code chaos in the future, which is also planned for end of this year. And we want to support native chaos workflows to achieve complete control in the experiment to make the execution faster. So the link is also there in the roadmap in this slide and also in the repo itself. So if you want to get involved in Litmus, these are some of the different sub-repositories, and the main, the area is at the top. So if you want to work in the control plane, you can check out these ones. If you want to work in the experiment, these ones, integration refs, and so on. So that's it from my side. These are some of the ways you can connect with the project. We are pretty much active on Slack in the Litmus channel. And we also have a project pavilion right now on the solution showcase, which is P5. So if you have any questions after this session, you can join me. Yeah, thank you. If anybody has any questions, yeah.
Probably just a very simple question, but your roadmap mentioned the distributed tracing bit, and
Yes.
I would just be curious if you have a bit more detail on what that looks like, specifically for the chaos and Litmus stuff, assuming the application itself, let's say, is already instrumented. So what will you guys add on?
So we have already instrumented it for Chaos Runner, Litmus Go, and a couple of other sub-repositories within the tooling itself. So whenever you run Litmus with your tooling, you'll be able to see the distributed tracing as part of the Litmus injection itself. So you have to use Jaeger as an integration with Litmus to be able to see it. So right now, it was just finished as part of the LFX Term 1. which just finished on the 31st. So it's still pretty fresh. We are having an ongoing effort to even branch it out. But right now, you have to integrate Jaeger with Litmus, and then you can see distributed tracing when you run chaos. Any other questions? All right, thank you so much.